Hello once again. Thank you very much for attending my talk and demonstration. It's a real honor for me to be able to host the event for you guys. I've looked at the feedback form and there are some questions and answers for me. So yeah, I'll use this video to answer them. So I'll try to answer them to the best of my abilities. If I do make mistakes, you can feel free to correct me. So yeah. So the first question is that he or she wants more hands-on time. Think due to the limited time of the 2.5 hours and the amount of audience, I think that was as much as I can give a hands-on time for everyone. However, if you are keen to learn more, think feel free to contact me. I'm sure I can work out some schedule, such as maybe some one-on-one lessons during the lunchtime or after work. So yeah. So the next question was like, beside the .stl file format, what are the other types of file formats that can be used in 3D printing? So I think this question is quite difficult actually, and I don't have much experience in it because I mainly use the .stl file format. So based on what I can research from Google, the common file extensions are OBJ and AMF. That there are others as well like VRML and all the others. But I think it's important to just realize that these file types are very dependent on what 3D printer you use and what is the 3D modeler software that you use. So in this case, we use like Fusion 360, and I think the preferred method for that software is the .stl file, as you can see from the drop-down menu. However, file types I think are very important because it determines like what information gets sent to the 3D printer. So for example, that if you want to 3D print something in color, the .stl file format would be not sufficient, because it doesn't contain that information. So that's why the file format is important. So make sure you ask the person that's going to help you 3D print like what format does he or she needs, and yeah. So just to add on to my previous answer, I just want to mention that there is also a file format called the AMF. There's also a standard for this file format that was published by the ASTM organization. Basically, it's an American standard organization. So yeah. So the next question was like, what are the factors that affect printing time? So off my head, there are probably three factors. Basically, it's the mechanism that your 3D printer use, the extruder, the heating mechanism, and its capability, the cooling rate, and part size. So in the next few slides, I'll explain these factors. So the mechanism that a 3D printer use. So in this picture, you can see that the mechanism used to move the extruder or the hot end from the left to the right. On the first picture, you can see it's actually a threaded screw. On the second picture, you can see it's a smooth rods with a belt on top. And next, you can see it's actually some kind of a linear rail or linear bearing that's used. So the type of mechanism used will affect how fast this extruder can move from left and right, and it will also affect how fast that you can actually print, and this will all affect your printing time. So the next factor that can affect the printing time would probably be the hot end extruder heating mechanism component. So basically there are two types of hot end typically. One type of hot end can handle the 1.75 diameter filament. The other hot end can handle the 3 mm diameter filament. So I believe the hot end that can handle the larger filament size can probably also deposit more plastic on during the process itself. Additionally, the extruder gear on the right, you can see that the filament is actually moving from up to down, mainly due to this drive gear and the bearing. So it depends, like if you move very fast, the drive gear might be like grinding onto your filament, and it's not effectively pushing your filament from the top to the bottom. So there's probably a certain speed that's limited by how efficiently this drive gear can push your filament downwards. Additionally, the filament they get pushed from downwards have to go through this heating mechanism. So if your heater is like not hot enough, then you cannot extrude out the plastic properly. So your speed has to be just right so that from the distance that the filament move from the drive gear to the nozzle, it is sufficiently melted to a state at which it can be extruded properly. So I think these factors in your extruder hot end would affect your printing time as well. So the last factor I can think of that affects printing time would be like layer thickness and cooling. So layer thickness, so in the 3D printing software, you can adjust your layer thickness. You can adjust your layer thickness to be like 300 microns, 200 microns, or 100 microns. So the layer thickness is simply the thickness of each layer as you print. So if you choose a smaller layer thickness, your printing time will obviously increase as well. So the next thing is cooling part size. So on the picture, you can see a pyramid. So as the pyramid part size become thinner and thinner and smaller, the feature of this pyramid get lost. It is lost because the part didn't have sufficient time to cool down, and as such, it is just like a blob of mass. It didn't have time to cool down and solidify. So on the picture on the right, you can also see three examples. The first example, there's like no cooling. Second examples, they are like inefficient cooling. And the third example is like perfect cooling. So the cooling of your part is important, and it will affect your printing time as well, because you don't want the printing time just to be very fast. You want the part quality to be good as well. So yeah. So that nicely brings us to the next question, which is like, what are the factors that affect printing quality? So off my head, there are like four factors. First is like layer thickness, mechanical components, STL file resolution, and material quality. I think mechanical components I've explained through the previous slides as well. Whether your 3D printer, the type of drive gear that your 3D printer uses, the type of hot end, the like type of nozzle size, whether your 3D printer is using like a threaded rod or belt or linear rail system. I think all these mechanical components actually have an effect on the printing quality. For the other three factors, I'll be explaining in the following slide. So yeah. So the first factor will be layer thickness. So like I said, layer thickness can be increased. So if you use like 100 microns, when you look at it, it will look like it is very fine. And when you compare it against like a 300 micron layer thickness, it is also important that I said that the mechanical component will determine like how accurately and how precisely each layer are stacked upon each other. So yeah. Additionally, it's important to note that if your part is simply just like a simple block geometry that is like vertically, even though you increase the resolution from like 300 microns per layer to 100 microns per layer, you will not see much of an effect. However, if your part has many slanting angles, many slopes, then by decreasing the printing layer to 100 microns as opposed to like 300 or 200 microns, you would see a visibly better part because each of the layer is finer as well. So yeah. So the next factor will be the STL file resolution. I think in this case I'll be only speaking of the .stl file resolution because I'm not very sure how the other file types represents the 3D model. So for the STL file format, basically it represents the 3D model by like segmenting the 3D model into triangles. So the how high of a resolution you set can be determined when you save the .stl file format. So you can see here that picture number 1 is your 3D model, and then picture number 2 is a very low resolution .stl file. Picture number 3 is a higher resolution .stl file, and picture number 4 is the best resolution .stl file resolution. So as you increase the resolution, then the more I think you'll visibly see the part quality getting better. If the amount of triangles are very little, then you'll see this faceted kind of a model being printed out. So yeah. So the last factor that I want to mention is like material quality. So the high quality filament versus an irregular filament, you will see an effect on the 3D printed part. So I think this is also very dependent on the 3D printing process. But in general, the better quality material you use, the better final part that you get. So yeah. So next, I think during the talk, I think I was a bit in a hurry because I wanted to finish on time. So I didn't really actually got the chance to like ask everyone whether do you guys really know the 3D printing process for after attending my talk and demonstration. So in this picture here, you can see a proposed process flow for 3D printing. So the first part is the CAD-based 3D model. In our case, we created our 3D model using Fusion 360. And the next step is to save this 3D model as a .stl file format. Next, when you input this .stl file format into the software, that in our case we use the UpStudio software, the software will help us to slice each of the layers. So it will slice the .stl file into individual layers so that it will give the correct instructions to the 3D printer to print. So the fourth step was to print the part layer by layer based on the slice layer from the previous step. And the fifth step is the post-processing. Like what you did, you remove the support materials from the part and you remove the support from the build platform. So I think this represents a very generic process flow of 3D printing. And I really hope that you, from this talk, you are able to form your own process flow on how 3D printers work. So yeah. So the last Q&A was that he or she wants me to mention a bit more about the parts that are in this desktop 3D printer. So from these two pictures, you can see the main parts. Basically, there are three motors in the x-axis, z-axis, y-axis. Basically, this motor helps to move the platform or the extruder or hot end in 3 dimensions. So you have 3 different motors. And then it's important to know that there is an extruder motor where in the previous slides you can see that there's a drive gear in it. And it's important to know that there is a hot end in which the nozzle is heated so that it can extrude out your filament. The material used is a plastic filament and it came from a filament spool. I think you see it in the event in the talk as well. And next there is also a printer control board. So it's like a circuit board that controls all the electronic of your 3D printer. Then there's also a power supply, and then it is connected to your PC as well. So this gives you a very generic understanding on the parts that are in this kind of a desktop 3D printers. So once again, I thank you all for attending my event. It's really an honor to have you guys. And hopefully this Q&A will answer some of your questions. If you still do have questions, so feel free to email me. Or you can visit me as well. We can arrange for some kind of appointment. So yeah, thank you very much once again. One last thing, I want to acknowledge the references, the pictures, informations, and the different sources in which I get my information from. I think without all these sources from all the different websites and from all the different organizations, I'm unable to provide this free talk and demonstration to you guys because a lot of my information is based on other people's work that they posted online. So I usually reference all the different sources through the web address below the pictures in which I took them from. So I thank you very much once again, and I couldn't have done it without all the different sources as well.